Hello and welcome to the latest installment of Introspect Technology's I3C video series. Today we will talk about sideband bus testing, and we will show how the Introspect SV4E I3C test module that's positioned here on the left in this image will talk directly to a JEDEC DDR5 module over the sideband bus. So we will start by launching the Introspect ESP software as usual, and we will start from a blank test procedure and slowly build up the program. So the Introspect ESP software supports multiple I3C protocols from the MIPI I3C version 1, version 1.1, I3C basic, and of course the sideband bus protocols and the JEDEC protocols. So the first thing we will do here is to just change the target protocol for the software. And so now we will be focusing on the JEDEC protocols. Then we will delete this automatically instantiated device and instantiate our sideband bus controller. So the hardware setup, as I have shown before, is the SV4E acting as a sideband bus controller, talking to a DDR5 DIMM with all the devices on it. So we will instantiate the sideband bus controller. And what this does is it creates a command at the bottom here to set up the sideband bus controller component class, and it sets it up according to the properties that are shown here at the top. So most properties are fine by default. I'll just change the HID to a more interesting number. And so now that's the sideband bus controller, and we will use it to communicate with the device under test. But before we do that, we should change the electrical levels on the bus because JEDEC wants 1 volt testing. So the SV4E I3C supports 1 volt and lower, so we'll set it to 1 volt. And then we will select only one port of the SV4E I3C. We do not need to instantiate all 4 ports within the I3C module. Our SV4E I3C is acting as a controller connected to port 1, and that's connected to an external target on the DDR5 DIMM. So with this, we're ready to perform some useful work with the I3C bus. And the first thing that's typically done with a DIMM is to reset it. So I'm pasting here some code to do a reset on the DIMM under test. In I3C, there are different ways to do resets, and JEDEC prefers the time-based reset. So this method here, called time-based reset, basically will perform a reset on the I3C bus, and then after that, we will send the broadcast CCC or reset the AA. And that's a simple operation just to get the device under test going and to get the bus going. So with that, we will connect to the Introspect module. And so the green light at the bottom here indicates that the module has been tethered to the PC successfully. And then we will click run. So when we run, the time-based reset actually takes 4 seconds. So there's a bit of a delay here. And then after that, if I go back to the log window, we sent the broadcast CCC reset DAA. And then the controller itself is already telling us that the operation has been performed successfully. So we already know that everything is fine. But we also started the protocol analyzer trace, and that will help us understand what exactly happened on the bus. And so what happened on the bus is there's a very long 4-second event here, which is the reset operation, the time-based reset, where the SCL is held low for a long time, and then both SCL and SDA are held high before the bus has been reset. And then after the bus is reset, we sent the broadcast's CCC reset DAA, and the protocol analyzer is showing us that everything is fine. So the controller told us that everything is fine, and then the protocol analyzer is essentially an independent check that's just monitoring the bus and checking if everything was okay. And it's telling us that both events happened. A reset, a time-based reset happened, followed by the reset DAA CCC. So from here on, we can send any command to the DIMM manually or through high-level methods. And so one of the high-level methods actually from Introspect is a very useful function called Initialize Bus. And what this does is it basically sends a series of CCCs already automatically so that you don't have to manually go and send them. So we will just send this operation to the DIM and see what happens on the bus. So we will just copy this comment here just to get a nice log. And then again, the component class is the SidebandBusController. We want to call a method on it called InitializeBus. And it does not need any arguments. Leave it there. And so now the test procedure consists of two main operations, really: resetting the DIM and then calling the InitializeBus command. So again, 4 seconds for the reset to complete, and then InitializeBus. And again, from the log, everything seems to be okay. The controller thinks that it has initialized the bus, and it has not assigned any dynamic addresses. We can look at the protocol analyzer trace itself and see what really happened on the line. So again, the reset DAA, that's the reset operation that we saw before. And when I click on it, we see all 4 phases basically of the CCC command, and the timing diagram is shown below. But then after that, there was a stop, and then a start. And then with that start, there was the different CCCs that are needed to properly initialize the bus. Set bus condition, DSEC, set HID, set ASA, and DAA, and NEC. These are all done automatically for you instead of having to write each of these commands manually. And if we just click on any one of them again, we go back to the state on the protocol analyzer trace, and we see basically everything that happened on the bus. And so no dynamic address assignment, of course, but here this is the NEC, and then we see all the responses. So this was a quick demo to show you how to set up the sideband-bus controller component. Thank you for watching, and make sure to follow the series for more useful videos and tutorials on the SV4E I3C testing debug module.